Yeah, Assalamu alaikum warahmatullahi wabarakatuh. Bismillah ar-Rahman ar-Rahim. Good evening, everyone. Welcome to all of the attendees for the evening webinar tonight for the title of Unleashing the Power of SCADA, the System Engineer Journey Throughout Technology and Industry. My name is Abdul-Moniem Al-Humoud. I am from Saudi Arabia with experience of more than 20 years. Let me introduce myself before we go through the presentation. So I graduated back in 2003 from the university, KFUPM, with system engineering. Then in the same year, I joined Zamel Steel as a normal system engineer. Then after 1 year, I joined Honeywell. I think brand name Honeywell is the automation company worldwide. In 2004, again, after 1 year, I joined SABIC as a client. So from vendor to client, and I worked there for about 8 years. Then in 2012, I joined an engineering company, Wood, for 1 year. Then I came back to Honeywell in 2013. Then after another 8 years, I joined Yokogawa as again vendor company and still working in Yokogawa. So let's start our journey for tonight. So please, if you have any question, you can type it directly on the chat. I can see all your messages in the chat. Just select my name there and type the message so I can read it directly and answer all your questions. So in my life, during the past 21 years, I have like 3 values I'm doing every day. So first one, be happy. So I am trying my best to be happy no matter what happened, no matter what gonna happen, no matter what happened. And second one, learn and learn. Learning is never stop. Whenever your age is, learning never stop. And the third one is whatever you are learning, what all knowledge you have, it's better you share, because if you share all these knowledges you have, these knowledge will be stuck in your mind and never lost. Okay, let's start. So in the chat, can anyone tell me what are you see on the screen? Can anyone explain what is this? Or also you can participate by your voice. Anyone would like to participate with his voice, just raise the hand and I will allow him to speak. Okay, I've seen Muhammad Nasri is mentioned control room, Ibrahim Saleh control room, Al-Af control and monitor room, Zahra Al-Aradi control room. More participations? Anything more than control room? Waiting for your participations. Yes, I have Hassan. Please open your mic. Mr. Hassan.
Yes, I can see like kind of let's say engineers monitoring some of systems, let's say, or something, which I don't know exactly what is it.
Okay.
But it's kind of monitoring something.
Oh, good. Thanks for your participation. Anyone else? Okay, I can see in the chat Ali Isa mentioning DCS, Abu Habib CCR, Batul, غرفة التحكم or control room. Okay, thanks all for your participations. Actually, this is a control room, or sometimes they call it centralized control room, where you can see the full area plans together in one place. And you can see these 2 engineers, let's say, monitoring the screens in front of them with some data, presenting some plant information. And at the back, there is one guy or one engineer sitting in front of the big monitor, and also he is monitoring some plant data and process or trends or whatever information coming from that plant. From this control room, you can monitor and you can control. So you monitor whatever happening outside in the plants, and you can control also from the same place. Okay, thank you all for your participation. Let's take one example before we start in deep detail. This is a plant, a small plant, consists of 3 tanks. There are many transmitters measuring some values. You can see here the liquid level on the left. Let me open the okay. You can see here on the left liquid level. So this transmitter is measuring the level on this tank. And you can see here above control to pump the liquid from this tank maybe to this tank. And you can see here a liquid level again. It will measure the level in this tank. This pressure transmitter to measure the pressure inside the tank, and this is flow rate installed in the pipeline to check the flow. And here also a temperature to measure the temperature inside this tank. This is another flow rate to measure the flow in this bath. So what can I see here in this drawing? So I can see 3 tanks, pump, transmitters, different measurement of the transmitters. Can anyone in the chat or can participate through voice tell me what are these transmitters or bumps or whatever measurement doing here? Can anyone chat? Let's have your participation. Waiting for your chat in the Zoom. Just type anything, no matter. Don't worry. Just tell anything in your mind. Okay, sending signals to the control room. Mr. Abbas, yes, you are right. Thanks. Ahmed Sensors, Ibrahim Al-Saleh to monitor the process. Zahra, field devices. Yes, you are all right. Okay, thank you all. Yes, as you just said, these transmitters, they are measuring the process and this plant. Just an example, for example, this liquid level, to measure this level in this tank, let's say if the level goes down, then transmitter will send the signal to this pump to start and have the liquid from this right-hand tank. It will pump the liquid to the left tank because the level measured by this transmitter is giving a signal. This will elaborate and requesting this pump to start. But these transmitters and sensors with pump here cannot do any control by themselves. All this has to be one controller to take the readings, read the readings, and give a control or give instructions to operate. So this is the purpose of the control. If you can remember, there is a closed loop or open loop for the control system. So the closed loop, you measure something, send it to the controller, and controller, based on this feedback, to send back to the machine or to the end. Sometimes they call it end point, and do the control based on the input. Okay. Again, here we are measuring level, flow, pressure, temperature, and sometimes multivariables. So these are the main measurement that we are measuring in any plants or industry, no matter what's the type of the industry. These kind of measurement transmitters or sensors using to measure these kind of measurement. This measurement, at the end, it will come to the system as a signal. We call it signals. And these types of signal consist of main 4 types: AI, AO, DI, DO. Can anyone tell me what does it mean, AI or AO, DI, DO? Anyone can participate in the chat or also through the voice by raising the hand. I'll open the mic for him. I've seen the chat, Muhammad Nasser, analog input. AI means analog input. Yes, you are right. Okay, Abu Habib, analog input, analog output. Zahra, analog and digital quantities. Muhammad Nasser, digital input and output. Ibrahim Al-Saleh, analog input, output, digital input, output. Yes, you are all right. Yes, so analog input means I am reading values, but they are numbers. Like, for example, level is an analog input. I'm reading level, for example, 50% level on the tank is analog input. Or I am reading pressure, or I'm reading temperature. For example, the temperature inside the tank is 70 degrees Celsius. So this is AI. If I am sending to the tank, for example, I need the temperature inside the tank to be 70%. So I am sending AO. So if I am sending from control room to the plant, we'll call it output. If I am receiving from the plant to the control room, I'll call it input. For DIDO, this is for a pulse or type of signals that either on or off. For example, I am receiving from the pump, it's on. So I'm receiving DI. Or I am sending to the pump, please start, and click on the control room and the monitor to the pump, start. So this start signal, it will go to the pump and it will be as DO. Okay, I hope it's clear. If all clear, please type on the chat 23. Let me see 23 if all clear. If anything is not clear, please type on the chat number 5 so I can repeat again. Okay, 23 or 5, let's see. I have 5. Okay. Let me repeat again. So we have 4 types of signals that transfer from the plant to the control room. We'll start the journey from the transmitters or pumps, for example, to the control room. If the signal transfer from plant to control room, we call it input. If the signal transfer from the control room to the plant, we call it output. If the signal numbers or percentage, we call it analog. If the signal's pulse or on-off or normal alarm, for example, we call it digital. I hope it's clear by now. We will have more example on this. Okay, this is another plant. There is one operator standing in front of the monitor. He's seeing the plant, and plant consists of many places very, very far away. He's using the signals media called fiber optic signals. So the media to transfer the signal from the plant to the control room is fiber optic. Here it's remote area. This is a platform inside the sea, a very remote area to the control room, sometimes hundreds of kilometers far away from the control room, a remote area. Here also we have a well, oil well, for example, to produce oil production, and also it's very remote area. We have storage tank and we have a plant where they'll take this oil and make the process. So all of these controlled by the operator sitting in the control room remotely. And please put 2 lines under the word remotely. because we're gonna use it later on. Okay, so now, as you can see, the signal transfer from the transmitters or sensors in the left, they will go to the control room far away in the right, but there are processes passing in the middle. So the signal or the cable, because signals cannot pass unless you have cable to transfer to or from, it will go to junction box in the plant, from each transmitter to the junction box. And from this junction box, we'll collect all the cables from one area, send it to the marshalling cabinet. They will collect all the cables from the field and put them in well-organized manner based on the type of the signal, based on the area. And then from the marshalling cabinet, it will transfer to the system cabinet, where you'll have DCS or PLC or the controller or SCADA, no matter what the type of the controller. Then from the controller, it will go to the station where operator can sit in the control room and control the plant. Is this chart clear for everyone? Again, I will ask the same question. If it's clear, please type 23. If you have any question, you can just raise it on the chat or type 5 so I can repeat it again. Let's wait for the participations. Also, if you have any question or any or if you would like to speak, just raise your hand. I'll open the mic directly for you. Okay, I can see all 23 means clear. Okay, what does PLC stand for? Okay, PLC is Programmable Logic Controller. It's a controller where you can program it to do a certain logic. For example, let's go back here. For example, you will write a logic. If this level goes to 30%, open this pump. If this level reach up to 90%, close this pump. So this is kind of logic. You are writing logic in the controller. It will take an action when there is a reading. Okay, there is another question from Abu Habib. Can you explain the protocol for transferring the signal? Yes. Here, we are transferring the signal through cables, but these signals transfer through plus minus 24 amps, and it will transfer to the controller. And then from the controller, it will be transferred as a PC signal. So it will take the milliamps in the transmitter. For example, they usually call it from 4 to 20 milliamps. If it's 4, means 0. If it's 20, means 100%. Okay, what's marshalling? Marshalling is a collection for the cables only. It will take the cables from the field, it will enter this cabinet, and it's a matter of reorganizing these cables in the marshalling and again send it back to the controller. Instead of sending directly from the field, it will sit on marshalling, just reorganize the cables, because you have many areas in the field with many cables. To organize them, it will be organized in the marshalling cabinet. Thanks, Ala, for your question. Okay, any other more questions before we move to the next? Okay, we'll go for the next point. Yes, it's a very good question here. The signals will not decrease over the distance. Actually, these field cables, they have a limitation. If the distance is short distance, you will use the normal cable. But if the distance is very long, like kilometers, it's better to use fiber optic. Yes, the signals will be decreased over the distance, but if you use the right cable, no, you will not lose any signal, or they will not decrease. Okay, next. As we just explained now in different presenting, now the field instrument, it will come to the marshalling. As you can see in the marshalling, you will have terminal blocks. You can see on the left side the field cables coming here. For each signal, you'll have two cables, plus and minus. It will become on this terminal blocks. They call it TBs. And then from the TVs, it will go to the controller. As you can see here, we have three types of controller: DCS, ESD, and RTU. DCS is for controlling the full plant. ESD, or sometimes they call it SIS, to take the safety of the plant, emergency shutdown system, to take care of the safety of the plant during any emergency, to take an immediate action to save the plant. RTUs, where you have remote terminal unit, and if you have any faraway distance of the plant to be controlled, it will be controlled by the remote controllers, or remote, they call it RTUs. And then we have the control room or stations where you can see all the plant, and you can monitor, you can control, you can have all the reports, all the trends in these stations. Okay, is it all clear up to now? Okay, clear. Okay, thank you all. Okay, next one. Again, it's just more in deep detail. Whatever we have seen earlier, it's a representation as actual. But now in documentation, how you present this? As you can see here, field instrument on the left, number one, then junction box. You have many transmitters, let's say 10 transmitters, they will come all in junction box. So you have 10 plus 10 cables, 20 cables here. And then junction box, you have only one cable going to the marshalling cabinet. Again, you rearrange the cables, and then you will go one cable in the system cabinet where you will have the controllers. And from the controllers in the system, you to see and check, monitor, control the plant from the operator console. We call it operator console. So this journey as actual, it's representing in terms of documentation. So in documentation, you will see a chart here, or a table, field, control room. So field, they will write, number one, the instrument name, for example, BT-001, to mention the instrument name. So for each individual instrument, you will have this kind of table. So number two, junction box, you will type the junction box number and in which terminal block these two cables are connected. So for example, here number one and number two. And again, from the junction box going to the marshalling cabinet inside the control room, in which TB, to mention the TB number 1 and 2 in this TB, and how it's connected. Then it will go to the, if there is any, like, for example, barrier or isolator, again, how it's connected. Then in the system cabinet, where you will have the controller, and in the IO card input, output card, where you will have analog input card, analog output card, or digital input or digital output card. And these will be configured in the system. It will mention here which station, which node, location, slot, blah, 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 all this kind of stuff. It will be configured in the controller itself. So with all this, you'll have also the tag name for each this instrument. Okay, is it all clear so far? 23 clear, 5 not clear. Can I see 23s or 5 in the chat? Okay, I have one question. What is the prefab cable? Yes, see here this line. where you have these cables. From the instrument to the junction box, it's two cables coming directly from the transmitter or sensor. And from the junction box to the marshalling, you'll have one cable with many cores inside. Cores means, for example, it will have maybe a 12 core, means 12 pair, 24 wires inside this cable. So they call this prefab. Already, this, instead of laying the whole 24 cables one by one, so to run only one cable with many wires inside. Okay, I hope it's clear. Let's go for the next. So here in the operator console, what you're gonna see in the plant. Let's have an example of this. You will have a monitor. We call it HMI, human. Can anyone tell me what's HMI represent for? I already mentioned the first word. HMI. Anyone can tell what's HMI? Yes. Okay. Muhammad Nasser, human machine interface. Abbas, human machine interface. Zahra, Ali Safar, Abu Habib, Munir. Yes, all right. Thanks all for your participation. Yes, human machine interface. We call it HMI or graphic representation. You will see all the plant representation here. You will see all the transmitters, valves, MOVs, tank, levels, pressure, whatever kind of information available for you in the plant. You can monitor from here. You can click on each, for example, valve, and click on it, and you can open, close the valve. So you can also control. On the left side, you can navigate for many graphics. For example, in the plant, you have many areas. You can navigate between the plants. You can navigate between the areas or tanks or machines. Okay, then you can also check about the history. For example, your last call-up page, last 20, it can be recalled and go to the previous pages. Similar like you are browsing for the internet. The good thing here, if you can click, for example, in one of the valves here, then you can check and see the history in that area and see all the previous data available for you to monitor. For example, you need to check the history for the level transmitter. How was the level in the tank for the past 1 month? It will show a trend for you mentioning the level for the last 1 month. Okay, is HMI is clear for everyone? You can see also the alarms. For example, if the level on the tank reaches to the 90%, this HMI will show you an alarm mentioning, hello, operator, there is an alarm of 90% in the tank, please take an action. Or if there is already configured controller, so the valve will close by itself based on the controller configuration. Okay, is it clear? So the next question for everyone now, whatever we mentioned earlier to describe the signals coming from the field to the control room, is it applicable for DCS, ESD, or SCADA? Or in the question in other wording, what are the differences between SCADA and DCS? Can anyone tell me what's the difference between SCADA and DCS? You can type on chat, or you can also participate by your voice. Just raise your hand, I'll open the mic for you. Anyone? Okay. Sahara, this is a station-based system. SCADA combine multiple DCS. Let's see. More participation, please. Let's have interaction. Okay. Anyone would like to participate via voice? Okay, Mr. Jason, please open your mic.
Hi, Mr.
Yes, hello.
SCADA is supervisor and data acquisition.
Mhm.
This is distributed control system. The SCADA is more software than hardware, which will be under SCADA DCS PLC. But DCS is sometimes multiple of unit FCS controller.
Okay.
So some people say it's not they're different, but there is difference between them. That's it for now.
Thanks for your
This
participation.
SCADA is for monitoring data in different location also, but this is for centralization.
Oh, good answer. Thanks for your participation. Thanks a lot. Okay. Thanks also for the guys who participate in the chat. Let's see the difference between SCADA and DCS. DCS usually it will monitor and control the plant nearby. Let's say you have the full plant available in one area, in one plant, industry. Just for example, I'll mention Babco, just an example. So Babco is a big industry plant. There will be a control room to monitor and control the full plant using DCS. So DCS is much bigger than the SCADA. SCADA, usually it will be used for third-party, let's say, systems connected to DCS, or it will be used for a remote control using, like, for example, RTUs, remote terminal units. This is the main difference between DCS and SCADA. So DCS is much bigger, higher in terms of capacity, control than SCADA. For the communication speed, usually DCS is much faster in terms of communication, more than SCADA. And DCS usually it will be used for short distance, but long distance will be used for SCADA. Cost-wise, DCS for sure is much costly than SCADA. It depends on the application. If you have a small application, you can use SCADA, but if you have a big application like plant or industry, it's better to use DCS. Also for the instrumentation type, usually instruments can be available in DCS and SCADA. But SCADA, usually it will be used for a long distance, so you'll have maybe more kind of network in between the instruments and the controllers. SCADA also usually it's collect data and presented in terms of graphics, trends, groups, or information, alarms you can control. DC is usually used for process. If you have a plant, tank, reformer, kind of process, chemicals, petrochemicals, refinery, usually used by DCS. This is the main differences between both. So tonight we are focusing about SCADA. We will not talk about DCS. We will not talk about the emergency shutdown system. We'll talk about the SCADA. If you can see on the right bottom side here, this is a representation of the control system in one of the plants, just an example. So you have here on the left a control room or console station, operator console station. So you can monitor the full plant from here. You have a DCS system to control the process of the plant. You have ESD or SIS system to monitor and control the safety of the plant, to take an action if there is an emergency in the plant. Here you have a third-party systems connected to the whole plant. So these will be controlled by SCADA. So just for example, you have a vibration monitoring system in the plant to monitor for a compressor, just an example. So this it will be connected to the full DCS as a third-party system using SCADA system. I hope the example and difference clear. Any question between the difference between SCADA and DCS? Just you can ask any type of questions. You can simply type on the chat. You can type it in Arabic, in English, no matter. Okay, I have one question, Manar. What companies use systems, SCADA or DCS? All companies in automation fields, they are having SCADA, ESD, DCS. Just I'll name few companies: Honeywell, Yokogawa, Emerson, Schneider, and other companies. So, like for example, Honeywell has its own controllers for DCS, ESD, and SCADA. Yokogawa, same. It has its own controllers for DCS, ESD, and SCADA. Emerson, the same. Schneider, the same. Other companies will have also the same. They have different names for each product, but functionality, they are most likely the same. Okay, so let's talk about SCADA now. Supervisory control and data acquisition. See, data word, it's there in the SCADA. So it means it's dealing with data most of the time. Okay, I have a question here in the chat. Could you repeat? Okay. See, the main difference, let's go back to this page. And the main difference between DCS and SCADA, the control philosophy. If you are controlling full industry, full plant, it's better to use DCS. If you are controlling short distance between the control room and the plant, it's better to use DCS. If you have an extremely huge plant, it's better again to use DCS. If you have a process like refinery, like chemical, it's better to use DCS. On the other hand, if you are using a remote area, for example, you are monitoring and control oil wells. Oils usually will be in the desert or in the sea, middle of the sea. So it's better to use SCADA to control and monitor these. This is remote. Most likely you will use it for data gathering. So you will collect data, you will do a small logic and do the control in SCADA. If long distance will be preferable, the SCADA to be used there. Also, it's much cheaper than DCS. If you have small plant, It's better to use SCADA, not to use the DCS. This is the major difference between both. Okay, so SCADA now. So SCADA, as we said, it's used for monitoring, controlling the industrial process, and collect data from sensors. So the sensors will send data to the control room. We call it output, as we said earlier. And the data or the commands sent by the operator to the plant, we call it output. So AIDI or AODO. The SCADA will analyze the data. It will take the measurement, analyze it, and then do an action based on these data. As we just mentioned, the example, if the tank level reached to the 90%, the command or the action will be taken to stop the pump. It can be configurable to do this action as a control, or the operator can take the action by himself. And finally, it will ensure the safe operation. So the operation will be safely controlled and monitored via SCADA. Okay, so SCADA, what is doing? It will do automation and control the plant. It will read the real-time data. So the real-time data, no delay on reading the data, the level, it will be read. It's 70%, it will send automatically to the control room with 70%. It will have optimization and efficiency. So operators sitting on the control room can read and control the full plant. And you can operate safely with the plant. It's SCADA using the HMI to monitor and control by the operators. We call it HMI. As you all mentioned, it's human-machine interface. So SCADA means supervisory control system. It will supervise the control area and take the right action. Usually for the remote areas, long distance, it will be used RTUs, remote terminal units. So these kind of controllers, it will be set in the far away, in the oil field, for example. It will take an action control and it will send the signal to the HMI or to the operator console. And again, it will collect the data as a history, and you can have your own trends and history. Okay. Again, we are repeating the same information, but in different presentations. So here we have the sensors at the bottom. We call it a plant. These sensors will send the signals to the RTU or to the PLC remotely. And these data will be collected by the SCADA. Sometimes the SCADA will be available remotely also. And these data will be collected and controlled and will send for the, we call it system-wide SCADA. Example, you have area number 1 and area number 2, number 3, number 4. Each area will have its RTU, PLC, and SCADA. And you can combine 2 areas in one SCADA, and you can combine the whole areas in one SCADA center, they call it. So they call it here SCADA layers, from layer 1 to layer 5. It depends on the plant philosophy and how it's configured. This is only an example. Okay. So what are the main parts of SCADA? First, field devices. There's a question from Manar. So SCADA architecture customized to plant company. Yes, it's true. Yes, you can customize the SCADA as per your requirement in the plant. We will talk about what system engineer do, and we'll talk about this. So the main parts of SCADA, field devices. So you will have the device that take the measurement of the field. For example, you have RTUs, you have sensors, you have transmitters. And second one, you have a communication network. What is the network to send the data from the sensors to the SCADA? Example of this network, fiber optic, wireless, satellite, and other technologies. Third one, SCADA software. So there's a software called SCADA, and this can be configured to enter all the data from the plant and do a control based on the reading. And operator can set to check in the HMI and to see, read, and control the plant from the software. And finally, you'll have historization and analysis for the data. So you can check for history, whatever happened earlier, select the tag name for the required to be historized, and you will have a trend for that. Just select, for example, a transmitter that collects the temperature of the water inside the tank for the last 2 weeks. So it will draw a chart for you. How was the temperature for the last 2 weeks? And then you can analyze these data and you can compare. Just an example, you can collect, if you have 5 tanks, you can compare the levels in the 5 tanks for the last 1 month, 2 months, for example. And you can make a comparison, you can have reports on that. Okay, these SCADA, where they are used, I just put 3 examples, but actually there are many examples. First one, manufacturing. If you have a small plant to have a production line, for example, oil industry, to take the oil from the wells and send it to the plant, you will use a SCADA. Sometimes you will use a SCADA in energy for the power if it's a small plant. For example, the energy, the green energy using the fans to generate the power from the wind. Instead of putting DCS, it will be very costly, and DCS is not. It will be like more what you need there. So it's better to put a SCADA there, a small SCADA using PLC, just for example. Also, SCADA, it's used very widely in the water treatment. So you will find many SCADAs there in the water treatment plant, because water treatment plant, they are simple plants. SCADA will be much better than DCS to be used there. Okay, before going to the system engineer, what he should do, let's have a small chat with you. So I hope everything clear so far from everyone. If everything clear for everyone, please type number 23. If you have a question, please type your question in the chat. I need to have 20 guys typing 23, then I will move to the next. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, still more 4. Okay, 19, one last one. Waiting for the last one. 19 so far. Okay, 20. Okay, thank you all. I hope everything clear. Let's move to the next subject. System engineer. Usually, if you are a system engineer dealing with SCADA, what you're gonna do, let's say you are working in the plant. First, you will do design for the plant. You will do design the SCADA network. You will design how many sensors you need to do there. You need to configure the logic in the SCADA itself. You need to configure the HMI for the operator. So this is one of the activities system engineer will do on SCADA. Second one, implementation and commissioning. Let's say you are having plant and you do all the configuration. Now you need to start this system. So you'll do a commissioning for this. Third one, you will do a normal maintenance and troubleshooting. Let's say you are working as a system engineer in the plant. If there is a problem, signal is not coming to the operator, so you need to troubleshoot that. What's the problem? Maybe wire is loose, maybe transmitter is down, maybe some drawing in the HMI is not clear. These type of troubleshooting you are doing on daily basis. And one very important system engineer need to be focused on to improve the whole system. Sometimes you will do migrations, upgrades, enlarging the systems. You need to improve that system by studying very well your system. What kind of skills for a system engineer need to be focused on to become an excellent system engineer in SCADA side? First skill is programming experience. So it's better to focus in programming because sometimes you need to configure some kind of logic. Use if statement, if this and this, please do that and that. If you have this action, please do that action. This kind of configuration. So you need a programming experience. Also, you need to have a skills on networking. You will connect many PCs to each other, connect controllers to PCs, servers. You need a kind of networking to configure them, especially the network between the RTU to the controller or to SCADA. Also, you need to understand your process where you are working in. If you are working in refinery, you need to understand the refinery. If you are working in water treatment plant, you need to understand that process very well. So you will configure the logic based on your understanding of that process. And then you need to have a very information and like awareness in the cybersecurity. You know, nowadays, cybersecurity is very important to know in all fields, not only in terms of SCADA or automation, in all kind of fields, cybersecurity is there. It's must to know everywhere. Okay, now, what are the challenges for the system engineer to focus on? So sometimes you have an old system in the plant and you are be part of the engineers to do full migration of that plant from old to new. Or if you have old system, how to maintain it, how to do a nice troubleshooting, so not to have a shutdown for the system. More, you can also focus how to make the system bigger. For example, you are adding a new tank to the system. So how to configure the SCADA to include this tank by low cost instead of paying for a bigger cost. If you know the information very well, so you will minimize the cost. Also, as a system engineer in the plant, one of the challenges to analyze the data through the years. You have the data for 2, 3, 5 years. So you can collect this data and make analysis through certain tools and have a full reports on this data. Then you can take an action. If from this data, just an example, you will have one, for example, valve having a trouble or failure for the last 20 years, 4, 5 times. Then you need to study why it has failure. And lastly, the cybersecurity threats. So we need to increase the cybersecurity in the plant. You need to check and monitor and measure all kind of security safety of the system. So how to enhance your SCADA capabilities? Again, introducing a new technology to the SCADA will improve the use of SCADA. Just just an example, the AI or IoT, industrial of things. So you can use these kind of technologies to improve the SCADA, and you need to learn as a system engineer working on SCADA to learn the new technologies that will enhance your system. It will improve the way you are doing daily activities of SCADA. Instead of doing one task in 4 or 5 days, you can do it in 1 hour. So what are the difference between the normal SCADA, we call it traditional SCADA, and the cloud-based SCADA or web SCADA, sometimes they call it. So in scalability, it's limited by the hardware. If you have 5 transmitters, you can do control of these only 5 transmitters. But in cloud-based, it's highly scaled. You can put in the cloud many transmitters. You can do certain analysis cloudly. Again, you can access the plant remotely. So if you are very far away, no need to go to the site and do troubleshooting. You can do it remotely. In terms of the data analysis, it depends of the resource available in the plant, but cloud-based, you can do all this remotely on the cloud and have many kind of data available for you. Let's have one example as a case study. Let me check the time now. Okay. As an example, if you have a water treatment plant, it's very old. You have valves, pumps, transmitters there. And since the plant is very old, so these transmitters sometimes giving a slow data or wrong data because they are very old, not maintained very well. So this is a challenge. What will be the right solution to this plan to invest like money, not costly, to put a lot of money as an investment on this, to introduce the IoT SCADA to the system or using the AI SCADA to the system. These will have improvement of the sensors. They will become a smart sensors. They will become a logic sensor. So they will take their own action by themselves if you introduce this technology to them. So this is one case study. By implementing the IoT or AI to the SCADA, you will have 30% reduction of water loss or 25% improvement in the energy efficiency and 40% decrease in expected downtime. You will not have shutdown because of the bad sensors, nobody taking care of that. So this is the beauty of using the latest technology. What is the future? We talk about future of the SCADA. So using the AI, machine learning in SCADA, these machine learning or AI will improve the system performance, will predict the failure before it happen. It will inform the operator you're gonna have failure after 1 week because of these kind of reasons, and it will give a nice report to the operator. In terms of communication, instead of using fiber optic or using a cable, normal cables or wireless, it's using the 5G integration. So it become fast, no need to lay any fiber optic cable. Also, it can be used in blockchain in the SCADA, so this will enhance the security and you can use it and you can have it in many other places widely. So by this, I ended my presentation. I am welcoming you all, and thanks for everyone who attended this webinar. And now the place for your questions. Anyone would like to have a question, please raise your hand. I will open the mic for you, or you can type your question on the chat.
Special thanks to our speaker. So if anyone has additional questions, feel free to type in the WhatsApp group or here in the Zoom.
Okay, let's wait for the questions. Any addition? No matter. No, if you don't have a question, you can just type any addition, any information. Okay, someone asking for a certificate. It's better to ask the organizer. They will answer you. Okay, I think everything clear for everyone since I don't have any question. Okay, Manar, you can take the lead now.
Okay, as we came to the end of today's webinar, I want to thank each of you for your participation and engagement. We have had an incredible discussion exploring how SCADA systems play a pivotal role in modern industrial operations. And SCADA is more than just a system. It's a powerful tool that drives efficiency, safety, and innovation across industries. And the knowledge shared today not only deepens our understanding, but also empowers us to harness the full potential of SCADA in our respective fields. So for both senior students and industry professionals, it provides deeper understanding of how large-scale automation and control system work in real-world application beyond the theoretical knowledge gained in the classroom. So you are building the gap between academia and industry by giving a first-hand look at the technologies and methodologies that are widely used in various sectors such as manufacturing, energy, and infrastructure. And also for professionals, this session enhances your technical knowledge by keeping you up to date with the latest advancements in SCADA technology. And it will give you practical insights for SCADA, for your internships, and for building your experience in system engineering. And a special thanks to our speaker, Engineer Abdul-Moniem, for your invaluable insights and expertise. We encourage everyone to continue exploring this subject and apply these learnings to enhance your work or studies. And don't forget to, if there is no certification provided, I suggest to have a screenshot of the webinar and put it in your LinkedIn page. It's just more than enough to show that you have attended this webinar. And thank you all for joining us today and for your active participation.
Okay, thank you all. See you inshallah later. Bye bye.